Hello everybody, this is Casey with Custom Extrusions 3D, and let me tell you, I am excited to introduce you to the Laser Master 2 from Ortur. Today we're going to be doing an unboxing and an assembly. Are you ready? Let's build. The Laser Master 2 is available in 3 different options: 7 watt, 15 watt, and 20 watt. Ortur sent me the 15 watt version for this video. It's important to note that the listed wattage is the input power. The optical output of the one I have is about 4 to 4.5 watts. Well, first up, we have 3 pages, a parts list, an important safety warning about the dangers while operating the laser, and a sheet explaining Ortur cares about the environment. Therefore, you have instructions on how to download a digital version of the user's guide, which includes the build instructions. Next, we have a bag of supplies, a handful of business card size wood planks, a dry erase marker, a dust brush, zip ties, a keyring sized piece of black acrylic, and the hardware and tools needed for assembly. We also have some additional hardware for that as well. Some belts, a bracket, the Y-axis limit switch. Then the all-important safety glasses. Always want to make sure you're wearing those. Next up is the mostly assembled X-axis gantry. The USB cable to connect the Laser Master 2 to your computer, the motor wiring, the main board and control interface, the fun bit, the laser module, the power cord, and the X-axis motor. Lastly, we have the aluminum extrusions that will make up the frame. I'll take this moment to highlight that this is a split wire loom insertion tool. It's only needed in the 7 watt version, so I won't be using it in this video. Alright, well, while I'm unpacking items from bags, including the hardware, that Y-axis limit switch, and feet, I'll recommend that you get a Phillips head screwdriver, a pair of needle nose pliers, and a tape measure or 3-foot long ruler. These aren't included, but they will be needed. So let's get started on assembly. I followed the link provided to download a zip file from Ortur that includes everything needed to move forward. Once unzipped, I opened the English version of the user manual. After a brief introduction and some key attention notes, we're looking at the assembly procedure. We start with the frame assembly, installing 2 corner braces on either end of one of the longer aluminum extrusions, being sure that they are placed in the groove on one of the sides that it's been drilled through. Note, I did not do this on my first attempt. Next, grab both of the shorter extrusions and fit them on the exposed portions of the corner braces. Turn the framing over so that you can install 2 of the longer screws through the pre-drilled holes. I always like to hand thread screws first to prevent any cross-threading. And sorry that was slightly out of frame. Next, tighten down the set screws on each of the corner braces using the supplied Allen wrench. Then, slide 2 square nuts onto the outside grooves of both the longer extrusions. You'll see here that I messed that up going on the inside. Don't worry though, I did fix it later. After that, install the other 2 corner braces in grooves that have pre-drilled holes on the last shorter extrusion and attach it to the rest of the frame using the last of the longest screws. Again, apologies for being out of the frame on that one. As I clear some space to lay the frame flat, it's my chance to say that having your frame square is really important. Here's where the tape measure or ruler come into handy. Measure from one corner to the corner diagonally across, taking note of the length. In my case, I measured just under 29 inches. Then measure the distance on the opposite 2 corners. My measurements were the same, but if yours are different, you'll need to adjust the alignment of the extrusions until they are. Lastly, tighten down the remaining set screws in each corner brace. Now we will be installing the X-axis gantry. The camera's perspective may make it difficult to tell, but the rollers will slide into grooves on the shorter extrusions of the frame. Up next are the rear feet of the Laser Master 2. Grab 2 of the 3 black acrylic feet, 4 medium screws, 2 flat washers, both timing belts, and the Allen wrench. Note, going forward I'm explaining sides in relation to how I'm facing the engraver. Starting with the right side, push one of the timing belts through the flat groove at the top of the foot about an inch. Then push one of the screws with a washer placed on it through the hole just below where the belt is protruding. Secure the screw, but don't tighten it completely just yet. Install the other screw, making sure the square nut is lined up to catch it on the back side. Then firmly tighten both screws. I'm using needle nose pliers to provide tension on the timing belt, which I will do later on the front side of the engraver as well. Repeat the process for the left rear foot. Here's a look at both rear feet installed. Our next step is to set the timing belts properly. Be sure to feed the belt under the first wheel, and then over the gear, and back under the second wheel. I found the Allen wrench to be helpful in guiding the belt along the way through this process. Repeat those last few steps on the left side as well. Also, be sure to take caution to keep the belt from having any twists in it during this process. Next, we'll install the right side front foot. Again, sides are in relation to how I'm facing the engraver. The steps are the same. Feed the belt through the flat groove. Feed a screw with a washer into the hole below the groove. Stretch the belt to provide tension. Then install the second screw. Now we install the Y-axis limit switch. Reviewing the instructions, it's important to note that the switch is to your left and the D-shaped hole that the belt will go through is on your right. Slide another square nut into the top groove on the aluminum extrusion. Feed the belt through the hole in the acrylic and place another medium screw through that same hole. It is a bit of a snug fit, so I suggest you tighten the belt a bit. Then place your screw through the hole before securing it into place. Don't worry too much about the exact placement, as it can be adjusted later for the proper triggering from the Y motor. Finally, we'll install the mainboard housing, which acts as the left foot. Slide your last previously fitted square nut into place and secure the bracket with 2 medium screws. I noticed some slack in the timing belt here, causing skipped steps as I checked the motion of the gantry on the Y-axis. So I tightened the belt from the rear of the engraver. I checked the motion twice more and made a final adjustment on the belt. No more skip steps, so let's move on. The X-axis motor is up next. As you prepare to install it, be sure to keep the wiring connection facing up. Take the 4 smallest screws and start by placing the motor through the brace from the back side. Then, thread the screws into each of the 4 mounting holes. It is helpful if your screwdriver has a magnetic tip, as access to the lower right hole is a bit challenging. Although I didn't do it here, I am recommending that you feed the belt over the gear on the motor before installing the screws. That way, you don't have to loosen and retighten the belt as I do here. But it can be done if you forget. Next, we will install the laser module. Anyone who has put together an ANET A8 can empathize with me here. Make sure you take the time to remove the protective paper from the mounting bracket. And after doing so, line up the longest straight side of the bracket parallel to the lower side of the laser, where the focus ring is. Use the final 2 medium screws to secure the bracket to the laser. Next, take the 4 end cap nuts and place the bracket over the 4 bolts on the X-axis gantry and tighten down each nut. While it may not be necessary, I follow what my dad taught me about car wheels. Tighten each cap nut a little at a time in a crisscrossing pattern. This will ensure there's no binding along the way. And be careful not to over-tighten them, as acrylic can crack with too much pressure. Just make sure they're snug, with no play. Now there are eccentric nuts on the top 2 rollers of the laser head assembly that can be adjusted to ensure there's no wobble. I ended up adjusting those later off camera. The final step in our assembly is the wiring. Pay attention to the small labeling, which can help in making sure you don't install it backwards. Each plug has raised grooves or a flexible clip, meaning they can only be installed in one direction. The 3-wire plug attaches to the laser, the 6-wire plug to the X motor. For the middle section of the wiring, the 4-pin plug coming from the laser goes on the top connector. The other 4-pin plug goes on the bottom connector, and the 6-pin plug goes to the Y motor. At the main board, the 2-pin limit switch goes into the middle, the 4-pin plug on top, and the 8-pin plug on bottom. Be sure to add in the provided zip ties to improve cable management and strain relief. Each of the 3 points where they are to be installed has a hole to thread it through, securing it in place. Also, after this is done, you can connect the engraver to your computer using the supplied USB cable and install the correct driver for your operating system. Within the zip file we downloaded earlier, there's a link to download a trial version of Lightburn. I won't run through how to install that today, but you can find many great tutorials on YouTube for that. Well, that ends the assembly of the Ortur Laser Master 2. Now let's get into running our first engraving. My suggestion is to head over to the official Ortur user group on Facebook, into the Files section, to download the Material Tester Lightburn file. And once you've opened Lightburn, open the file we just downloaded. Note if you get the same font error I receive here, you can click OK and ignore it. Be sure to highlight everything that was just imported because we need to rescale it to fit the size of one of our wood samples that came with the Laser Master 2. The icons at the corners help maintain the right aspect ratio. Once it's positioned where you want, then you can select the appropriate COM port for communication. It's always a good idea to click Frame to make sure your material is aligned properly. Once you feel good about the placement, click Start. Just a note, this process that you're watching now has been sped up 8 times faster than normal to save us some time in this tutorial. After starting the burn, I noticed I didn't quite get it lined up the way I wanted to. Well, not too bad for my first engraving ever. Still smoking. As you can see, the Laser Master 2 from Ortur has plenty of power. Here's your PSA to read over all the safety information. Lasers are dangerous. Results will vary for a number of different reasons. Material selection and the focus of the laser beam are 2 of the biggest. Personally, this is a test I will be running on all the materials I plan to use with the engraver. Well, I hope you found that entertaining and educational. If you have any questions, leave a comment below. If you found it useful, be sure to like and subscribe. We'll catch you later. Now get out there and create.